Okay, in this video, we're going to be talking about a few more basic definitions that we really need to know we're going to be using all throughout this geometry course. The first one's being associated with angles. So let's talk about how we name angles, what an angle actually is. Starting with the definition, an angle, which we see here in the picture, is formed by two, now these are rays. And remember that a ray starts at a point and goes forever in a single direction. Now, these could actually be made up of line segments, but we'll go along with this. Made up of two rays with a common endpoint. Notice what I mean by common endpoint. Both of those rays start right here at point B. This common endpoint is called the vertex of the angle. So it's called the vertex. So point B right here is the vertex. It's where your angle starts. The rays BA and BC are called the sides. So they're the sides of the angle. We name an angle using three letters. Now this next part is super important. The middle letter must always be the vertex. The middle letter is the vertex. So we'll talk about in a second how to name this. Now there is another option. We can use a single letter. Okay, we're going to use three with the middle of the vertex, or we can just use a single letter if there's only one angle at that vertex. Okay, so this angle over here, let's talk about the two different ways, or actually a few different ways we can name it. This angle over here is angle. We put the symbol in front. I like to put the little arc through it. This is angle A, B, C. Notice the middle letter right here. We're going to use 3 points. The middle letter has to be the vertex. So you could actually go in the other direction as well. You could also call this angle C, B, A. But again, notice the B is the middle letter. Since this is the only angle that's located at this vertex, we could actually also call this angle B. So any of these names would be fine. When referring to the measure of an angle, use a little m. So like here, the example, this angle over here, angle ABC or CBA or angle B that we've been talking about, if you put a little m in front of it, that means the measure. It means how big it is. Now this angle is a 60-degree angle. Now let's talk a little bit more about measuring angles and actually what 60 degrees is. I want you to think of an angle as being like opening a door. This is the hinge of your door, okay? And here's where your door starts. If the door was down here, here's the door. If the door was right here, if it was closed, that is 0 degrees. Okay, as you begin opening the door, okay, you open it a little bit more, all depending on how open the door is, that's how many degrees that you have. As soon as you hit this angle, we'll talk more about this in a second, this is a 90 degree, okay, so it's half open there. And then you open it up the rest of the way to where if this is closed, if it's open all the way back up to here, that's going to be what we refer to as 180 degrees. Okay, so let's go through those types of angles, kind of what I was talking about there. If your door was closed, again, it would be right here. But we've started opening that door. Okay, but we've not yet hit that 90 degrees I was talking about. If you're smaller than 90, if your door is not open to a 90, this is called an acute angle. If you've passed that 90, okay, it's referred to as an obtuse angle. So acute, let's label this. Acute was less than 90. We've not yet hit 90 degrees. Obtuse was between 90 degrees. We're past 90. And we've not yet hit 180 degrees, which would be all the way open. A right angle, I've already told you what that was. We've opened it up to that 90 degree mark. And if we open up all the way, that's a 180 degree angle, okay, that we've opened that doors. And that's called a straight angle. Okay, now let's work some examples. And these next few examples are just giving us practice with those vocabulary words that we've that we just learned about angles. Name the vertex. Again, the vertex is the common endpoint of the two rays here. So the vertex here would be point K. Notice I put that point symbol before it. Name the sides of the angle. Now, both of these sides are rays. So you have this ray that goes this direction. It starts at K, and it's very important that you use the starting point. It goes from K, and it goes through J, and it is, again, a ray. The other ray starts at K and goes through L. So that would be starts at K, goes through L. That'd be ray KL. Again, those Ks must be first because that's where it starts. That's the origin. That's the vertex. You have three ways to name this angle. Make sure, once again, that your vertex is in the middle, but we're going to call this angle. We could do J, K, L. K's in the middle. We could go in the other direction and name it angle L, K, J. K's in the middle. But this is the only angle at that vertex, so we can just say angle K since it's the only one. Now, classifying it, is it acute, obtuse, right, or straight? If you were to swing this thing back, again, this is kind of where our starting point here. And then we start opening the door. We passed 90 and we went further, but we're not yet at 180, so this is an obtuse angle. Example number 2, name the vertex. The vertex is the common point shared by the two rays, so point S is your vertex. Name the sides. The sides are the two rays, which would be ray S through T. And the other one starts at S and goes through R. That's your two rays, the two sides. Three ways to name the angle. Again, make sure the vertex is in the middle. This could be angle RST, or it could be angle TSR. Again, notice with both of them, the vertex is in the middle. That is the only angle at this point, so we could just name it angle S. Finally, it says classify the angle. This right here is how we're going to classify it. That box, anytime you see that box, that means that this is a 90-degree angle. Very important that you know what the box means. So since that is a 90-degree angle, that would be a right angle. Congruent angles. What does it mean for two angles to be congruent? If the measure of angle A is equal to, and I remind you the little m right there means, well, how big is the angle? Now, we did this before. If we were talking about a line segment, remember before I had a line segment? Well, what if I'm talking about how long the line segment is? Then we did just the A and the B without the symbol at the top. This was talking about how big it is. Now, this is talking about the shape itself. We're doing the same thing with angles. Okay, we're not talking about how this angle, we're talking about how big the angle is. That would be called the measure of it, how big. So if the measure of angle B is equal to the measure, or measure of angle A is equal to the measure of angle B, these two have the same measure, then they are congruent. This is written as angle A is congruent to angle B. And again, I told you the relationship last video that if the measurements are the same, that's what makes them congruent. Why are they congruent? What does it mean to be congruent? That means they have the same measures. Okay, measurements are equal shapes. Now this is talking about the shape itself. Shapes are congruent. An angle bisector. Now, that word looks familiar. We talked about a bisector a couple of videos ago. To bisect means cut in half. So therefore, an angle bisector is a ray. Now, this could, later on we'll talk more about it, but this could actually be a line segment as well, or a line. A ray that divides an angle into two congruent angles. It cuts it. Right here, BD slices this into an angle here and an angle here that are congruent. Okay, it is called an angle bisector. Why? Because it bisects this big angle. It cuts this big angle into two equal pieces. That's very important. That is, the pieces have to be congruent. In the diagram at the right, blank is an angle bisector. Well, that would be the ray in the middle there. Ray BD would be an angle bisector. BD slices it into two congruent parts. BD is an angle bisector, therefore, okay, since this cuts it into two equal parts, we know that this angle here and this angle here, those two angles have to be the same. So therefore, we would know that angle ABD, which is ABD, follow the letters, would have to be now congruent to angle DBC. Why? Because BD cut it into two congruent parts. Next up, let's define the words perpendicular lines. Perpendicular lines are two lines that intersect at a right angle. Notice here line L and line M, they cross, but it's very special about where they cross. They cross to form right angles. Now these would not be perpendicular because these are not right angles. It's very important that in order to be perpendicular, when they cross, they form right angles. And not only one, but look, if that's 90, that'd be 90, that'd be 90. They actually form four right angles when they're perpendicular. The symbol for perpendicular is an upside down T. Why? Because that's a 90 and that's a 90. So therefore, upside down T is perpendicular. In the diagram at the right, line L is perpendicular to line M. Whoops. There you go. That's what it means to be perpendicular. Now let's kind of put those two things together and let's talk about what does it mean to be a perpendicular bisector. Well, you can tell by the actual words itself. Well, perpendicular bisector, I think you already know what that's going to mean. So by definition, a line, a segment, or a ray that is perpendicular. Okay, think about it. Perpendicular and bisector. It's perpendicular to a segment at its midpoint. So what does that mean? It's perpendicular and it cuts it in half. In the diagram at the right, LM, line LM, you see line LM. Notice what line LM does. Line LM is perpendicular, and not only that, since this and this are the same, that means this must be the middle. So that means that line LM cuts through the middle. What does it mean to cut through the middle? That means it bisects it. So not only is it perpendicular, but it also bisects PQ. So therefore, LM is the perpendicular bisector to PQ. And PQ is a line segment. Now be careful with this because does it work for both? LM is the perpendicular bisector of PQ, but is PQ the perpendicular bisector of LM? No. Why is that? Because they're perpendicular. PQ is also perpendicular to LM, but is this the middle of LM? And I can answer that very quick. No, there's no way it can be. I want to point out that LM is a line. Can you cut through the middle of a line? No, lines go forever. Lines don't have middles. So you got to be careful. You can find the perpendicular bisector of a line segment because a line segment has a middle, but a line does not have a middle. Okay, some examples now. It says write another name for angle CBF. And what I like to do is come over here and find C, find B, and find F. And actually draw out that angle CBF. And we're looking for another name for angle CBF. And we can just flip-flop again, you name angles with three letters. So one way we can just flip-flop the letters around. And instead of doing C to B to F, let's do F to B to C. Now, again, you got to be very careful that B has to be in the middle because it's the vertex. Number two, or letter B, says name the sides. Let me erase that. Name the sides of angle EBD. So let's find E to B and then to D. So we're looking for the sides. The sides are the two rays or line segments that make up the sides. So that would be ray BE, would be one of the sides, and it is a ray. The other side would go from B to D. That's the other side. So ray BD. Again, make sure that since they're rays, you always have to start with the letter that the ray starts from. C, we're classifying an angle. We're classifying angle ABC. So here is A, here is B, and here is C. And I want to point out, well, that's a straight line. So that's not an angle. Well, yes, actually it is. Um, Again, it's like saying it's like a door. It's like the door starts here and you open it all the way to here when you're talking about the angle. Okay, when you're measuring an angle, or you can say, well, the door starts down here and then you open it up to here. It doesn't matter which way you're opening it up. It's a straight line or a straight angle. And I'll put the angle symbol, a straight angle. And you can, just to make sure that you won't forget, it's a straight angle because it's 180 degrees straight line. D part, give an example of an obtuse angle. So an obtuse angle is any angle bigger than 90. And I'll point out here that here's you a 90-degree angle. So it's got to be bigger than that, but it can't be quite 180. So since that's a 90, I think I see another 90 right here. This might help. So if I were to open it from here to here, I've opened at 90. But if I go anything further than that, then I've went 180. So why not use this angle? Because we know that's bigger than 90 from here to there, and that's not quite a straight line. So that would be angle D to B to E would be an obtuse angle there. E part, name two congruent angles. Okay, congruence is marked by arcs. If you notice here, this has a single arc and this has a single arc at here. Anytime you see those arcs, that's telling you that those angles are the same side. They're congruent. So therefore, here my congruent angles would be angle ABE. And just to get some more practice with our symbols, I'm going to put angle ABE is congruent to angle, because they're saying find two congruent. This angle here, which would be CBF. Very important again to point out that the B is in the middle because it's the vertex. And the last one, name a perpendicular bisector. So we're looking for, well, let's try to find our bisector first. And I point out that, hey, look, these are equal. So this right here has to be the midpoint of this line segment. Okay, the distance from A to B and the distance from B to C are the same. And this line segment, or this ray right here, you see that this ray is also perpendicular and it passes through the midpoint. So our perpendicular bisector is ray BD. Example number 4. Name the vertex of angle 2. Now another name that you can, or another way that you can name angles, and they didn't discuss this in the top, in the notes, but you can also name angles with numbers. And sometimes this is actually the best way. Angle 2, if you'll just look for the number 2, and this angle right here, that's where the number 2 is. So that blue angle right there, that would have to be angle 2. So the vertex of angle 2 would be this point right here, which is point T. Name the sides of angle 4. Okay, let's highlight angle 4 here. Here's the number 4. Here's the angle that number 4 is naming. So name the sides of angle 4. That would be this side, which starts at T and goes through W. So that would be ray TW. And this side starts at T and goes through Z. So that'd be ray TZ. What's another name for angle 3? There is angle 3. Another name, we can actually use these letters to name it. So let's make sure that our vertex is in the middle. So you can either say angle UTZ, again, U to T to Z, or you can do that backwards. Z to U would also be the correct answer. Another name for angle 1. Here's a 90-degree angle 1 right here. So another name for that, again, make sure that you can use the letters. That'd be YTX, so angle YTX, or you could say XTY, as long as T is in the middle. Classify angle YTW. So find Y, find T, and then find W. And ask yourself how big this is, and it tells you right there. That's a 90-degree angle, so it is a right angle. And I'm going to put 90 degrees in parentheses. Classify YTU. Well, we've already found Y to T. There's Y to T. Here is U. Y to T to U would be this. This is a 90 degree, so that has to be bigger than 90, so that'd be an obtuse angle because it's greater than 90 and also less than 180. XTU, let's find XT and U. XTU would be definitely smaller than 90. That'd be an acute angle because it is less than 90 degrees. And then finally, WTX. I bet I know what this one's going to be. W to T to X. That's opened up all the way. So that's 180 or a straight angle. Straight. And it is straight because it is a 180-degree angle. To be continued. More on that to come. Name two perpendicular lines. Perpendicular lines are two lines that cross to form right angles. So therefore, since our right angle is right here, that means that this line would have to be perpendicular to this line. So my perpendicular lines, and you can name lines with any 2 points. So this line, you can name several different ways. You could say YT, YZ, ZT, ZY. I'm going to name it Y and Z, which are the outermost points. So line YZ is perpendicular to this line, which you can again say WT, WX, XT, XW. We'll use W and X. So those are my perpendicular lines, and I even use my perpendicular notation. Name an angle bisector. Okay, in order to be an angle bisector, you have to cut the angle into two congruent pieces. Since this is congruent to this, then this must have bisected that angle. So your angle bisector there is TU, and TU is a ray.